How does IRQ work in embedded systems? Have you ever wondered how embedded systems manage to respond to multiple events at once? One key player in this process is the interrupt request, often abbreviated as IRQ. This hardware signal is vital for ensuring that processors can react to urgent events without delay. Let's break down how this works in a straightforward way. When a peripheral device or an internal component needs immediate attention, it sends an IRQ signal to the processor. This could happen when a timer reaches a certain value, data arrives on a communication interface, or a sensor is triggered. The processor is designed to detect these IRQ signals through dedicated hardware that constantly monitors interrupt lines. Once the processor recognizes an IRQ, it temporarily halts its current task. It does this by saving the program counter and relevant registers to a stack, which preserves the machine state. After saving this information, the processor jumps to a specific memory address. This address is defined in what is known as an interrupt vector table. This table contains the starting addresses of interrupt service routines, commonly referred to as ISRs. The ISR is a specialized function that quickly handles the interrupt event. For example, it might read data from a sensor, clear interrupt flags, or update status variables. To keep the system running smoothly, ISRs are designed to be short. This prevents them from blocking other interrupts or delaying the main program. Software also plays a role in managing interrupts. It can enable or disable interrupts globally or for specific devices using control registers and interrupt enable bits. This capability allows systems to prioritize certain interrupts and avoid conflicts. In more complex systems with multiple interrupt sources, a nested interrupt controller, like the nested vectored interrupt controller in ARM Cortex and microcontrollers, manages priorities. This ensures that higher priority interrupts are serviced first. Practically, IRQs are essential for handling asynchronous events in embedded systems. They manage timed operations through timer interrupts for periodic tasks. They also facilitate communication protocols such as Universal Asynchronous Receiver Transmitter, Serial Peripheral Interface, or Inter-Integrated Circuit, which signal data availability. Additionally, IRQs respond to external input signals from buttons or sensors that requiring immediate action. They even address fault or error conditions that need urgent attention. This interrupt-driven approach is vital for meeting real-time constraints. It reduces the idle time of the central processing unit compared to polling methods and boosts overall system efficiency and responsiveness. Understanding how IRQs work helps in designing better embedded systems that can handle multiple tasks effectively.